F-101 Voodoo. The F-101 Voodoo was developed in the early 1950s as a long-range, high-speed fighter for the United States Air Force. It was originally conceived as a long-range bomber escort, meaning it would protect strategic bombers on deep penetration missions into enemy territory. However, as aerial warfare doctrine changed and intercontinental missiles reduced the bomber escort role, the aircraft evolved into other specialized missions. The F-101 used two powerful turbojet engines with afterburners, allowing it to exceed Mach 1.5. Its long, slender fuselage and swept wings were designed to reduce aerodynamic drag at supersonic speeds. High speed was essential for interception missions. An interceptor is a fighter designed to rapidly climb and engage incoming enemy bombers before they reach their targets. One of the Voodoo's most important roles became reconnaissance. The RF-101 variant was equipped with high-resolution cameras instead of internal weapons. Reconnaissance aircraft gather intelligence by photographing enemy positions, missile sites, airfields, and troop movements. During the Cuban Missile Crisis, RF-101 aircraft conducted critical overflights that confirmed the presence of Soviet missile installations in Cuba. These missions required high speed and high altitude to minimize vulnerability to enemy defenses. F-102 Delta Dagger. The F-102 Delta Dagger was developed in the early 1950s as the United States Air Force's first operational Delta Wing interceptor. An interceptor is a fighter designed specifically to detect, pursue, and destroy incoming enemy bombers before they can reach their targets. During the Cold War, the primary threat was large formations of Soviet long-range bombers carrying nuclear weapons, so speed, altitude, and radar capability were prioritized over close-range maneuverability. The aircraft's defining feature was its delta wing design. A delta wing is triangular in shape, with a broad base near the fuselage and a pointed tip. This configuration provides good structural strength and stability at high speeds, particularly near and beyond the speed of sound. Early prototypes of the F-102 struggled to break the sound barrier due to excessive aerodynamic drag. Engineers solved this by applying the area rule, which reshaped the fuselage to reduce drag by smoothing changes in cross-sectional area along the aircraft's length. After this modification, the F-102 successfully achieved supersonic flight. F-8 Crusader. The F-8 Crusader was developed by Vought in the mid-1950s as a carrier-based air superiority fighter for the United States Navy. A carrier-based aircraft is specifically engineered to take off and land on aircraft carriers, which requires reinforced landing gear, folding wings for storage, and strong structural design to withstand catapult launches and arrested landings. The defining feature of the F-8 was its variable incidence wing. Instead of lowering the entire nose during landing, the wing itself could tilt upward. This allowed the aircraft to maintain better pilot visibility while still generating the high lift required for slow carrier landings. Lift is the upward force generated by airflow over the wings, and increasing the wing's angle improves lift at lower speeds. The Crusader was powered by a single afterburning turbojet engine. An afterburner injects extra fuel into the exhaust stream to create additional thrust, allowing the aircraft to exceed the speed of sound. The F-8 could reach speeds over Mach 1.5, meaning 1.5 times the speed of sound. This speed, combined with strong climb performance, made it effective in intercepting enemy aircraft. F-104 Starfighter. The F-104 Starfighter was developed in the late 1950s as a high-speed, high-altitude interceptor. Its design prioritized maximum speed and climb rate to intercept enemy aircraft quickly, especially bombers operating at high altitudes. The aircraft was powered by a single afterburning turbojet engine capable of propelling it beyond Mach 2, or twice the speed of sound. The F-104's most distinctive feature was its extremely thin, straight wings. These stubby wings minimize drag at supersonic speeds, but provided little lift at low speeds, making takeoff and landing challenging. Because of this, the aircraft required long runways and precise pilot control. The nickname "missile with a man in it" refers to its slim fuselage, high speed, and rapid climb characteristics that made it resemble a piloted missile. F-5 Freedom Fighter. The F-5 Freedom Fighter was designed by Northrop in the late 1950s as a lightweight, low-cost supersonic fighter. Its core purpose was simplicity. Unlike larger, more complex fighters of the era, the F-5 used two small turbojet engines, a compact airframe, and straightforward avionics. This reduced maintenance demands and operating costs, which made it attractive to allied nations with limited defense budgets. Aerodynamically, the F-5 used a thin, swept wing and a narrow fuselage to reduce drag at high speed. Supersonic means it could fly faster than the speed of sound, roughly 1,235 kilometers per hour at sea level. Its lightweight gave it strong acceleration and tight turning ability, meaning it could change direction quickly in a dogfight. Dogfighting refers to close-range air-to-air combat between fighter jets. The aircraft was armed with internal cannons and could carry air-to-air missiles and bombs on external pylons mounted under the wings. External pylons are hardpoints that allow weapons or fuel tanks to be attached. In the Vietnam War, F-5s were evaluated in combat to test their effectiveness. Although not the primary frontline U.S. fighter, the aircraft proved reliable and durable in harsh operating conditions. F-4 Phantom II. The F-4 Phantom II was developed in the late 1950s as a twin-engine, two-seat, long-range supersonic fighter. Unlike earlier fighters designed strictly for air-to-air combat, the F-4 was built as a multi-role aircraft. A multi-role fighter is capable of performing different mission types, including air superiority, ground attack, interception, and reconnaissance. This flexibility made the F-4 one of the most widely used American combat aircraft of the Cold War. The aircraft was powered by two afterburning turbojet engines, giving it a top speed of over Mach 2, which is more than twice the speed of sound. The twin-engine configuration increased thrust and improved survivability. If one engine failed or was damaged, the aircraft could sometimes continue flying on the other. The F-4's large size allowed it to carry a heavy payload of missiles and bombs, far greater than most earlier fighters. F-14 Tomcat. The F-14 Tomcat was developed in the late 1960s as a long-range, carrier-based air superiority fighter for the United States Navy. Its primary mission was fleet defense. Fleet defense means protecting aircraft carriers and naval strike groups from long-range threats, such as enemy bombers and anti-ship missiles. To accomplish this, the F-14 was designed with powerful radar, long-range missiles, and high speed. The Tomcat's most distinctive feature was its variable sweep wing. This design allowed the wings to pivot backward or forward during flight. When extended forward, the wings generated more lift at lower speeds, improving maneuverability and carrier landing performance. When swept backward, the wings reduced drag at high speeds, allowing the aircraft to exceed Mach 2. This adaptability gave the F-14 strong performance across a wide range of flight conditions. The aircraft was powered by two afterburning turbofan engines. Twin engines provided both high thrust and redundancy in case of damage or mechanical failure. Early variants had engine reliability challenges, but later improvements enhanced performance and safety. The F-14 also featured a two-seat cockpit, a pilot in the front and a radar intercept officer, or RIO, in the rear. The RIO managed the radar system and missile targeting, allowing the pilot to focus on flying and combat maneuvering. F-16 Fighting Falcon. The F-16 Fighting Falcon was developed in the 1970s as a lightweight air superiority fighter, but it evolved into one of the most capable multi-role aircraft ever built. The original design philosophy focused on agility, energy retention, and pilot visibility. Energy retention refers to an aircraft's ability to maintain speed and maneuvering power during combat turns. This is critical in dogfighting, where losing speed can make an aircraft vulnerable. The F-16 is powered by a single turbofan engine with afterburner. A turbofan engine uses a large fan to move air efficiently, providing better fuel economy than older turbojets while still allowing high thrust. With afterburner engaged, the F-16 can exceed Mach 2. Despite having only one engine, it delivers high thrust-to-weight ratio, meaning the engine produces more thrust relative to the aircraft's weight. This allows rapid acceleration and strong climb performance. One of the F-16's most important innovations was its fly-by-wire flight control system. Traditional aircraft use mechanical linkages between the pilot's controls and control surfaces. Fly-by-wire replaces those linkages with electronic signals. Computers interpret pilot inputs and adjust control surfaces for optimal performance. This allowed engineers to design the F-16 with a naturally unstable airframe, which increases maneuverability. The onboard computer constantly makes micro-adjustments to keep the aircraft stable in flight. F-117 Nighthawk. The F-117 Nighthawk was the first operational aircraft built specifically around stealth technology. Stealth does not mean invisible. It means designed to reduce detection by radar, infrared sensors, and other tracking systems. The F-117 achieved this by minimizing its radar cross-section, which is the amount of radar energy reflected back to enemy radar systems. Its most recognizable feature was its angular, faceted shape. Instead of smooth curves, the aircraft was made up of flat panels set at specific angles. These angles were carefully calculated so incoming radar waves would scatter away from the radar source rather than reflect directly back. This design made the aircraft appear extremely small, or even undetectable on radar screens. Later stealth aircraft would use smoother shapes, but the F-117's design was based on early stealth mathematics and computing limits. The aircraft was powered by two turbofan engines, but unlike many fighters, it did not rely on speed or maneuverability for survival. In fact, it was subsonic and not designed for air-to-air combat. Its mission was precision ground attack. All weapons were carried internally in a weapons bay to preserve stealth characteristics. External weapons would increase radar reflections and defeat the purpose of the design. T-45 Goshawk. The T-45 Goshawk is a carrier-capable jet trainer developed for the United States Navy to prepare pilots for frontline combat aircraft. Unlike operational fighters designed for combat missions, a trainer aircraft is built specifically to teach pilots advanced flight skills, including high-speed handling, instrument navigation, formation flying, and carrier landings. The T-45 bridges the gap between basic flight training aircraft and high-performance naval fighters. The aircraft is based on the British BAE Hawk design, but modified extensively for carrier operations. Carrier operations require reinforced landing gear to withstand the impact of arrested landings. An arrested landing occurs when the aircraft catches a steel cable on the carrier deck using a tailhook, rapidly stopping the aircraft over a short distance. The T-45 also includes strengthened airframe structures and systems compatible with catapult launches. F-20 Tigershark. The F-20 Tigershark was developed in the late 1970s and early 1980s as an improved, export-oriented version of the F-5E Freedom Fighter. Its primary goal was to offer a cost-effective, highly maneuverable fighter for allied nations that required modern air capabilities without the complexity and cost of the latest U.S. frontline fighters. Despite being fully flight-capable, the F-20 never entered production. The aircraft was powered by a single afterburning turbofan engine, providing high thrust-to-weight ratio for rapid acceleration and tight maneuvering. Its airframe design emphasized aerodynamic efficiency, stability, and agility in both air-to-air and limited air-to-ground operations. Like the F-16, it incorporated a bubble canopy for excellent all-around pilot visibility and a reclined seat to reduce the physical strain from high-G maneuvers. F-19 stealth fighter concept. The F-19 was a fictional stealth fighter popularized in the 1980s, imagined to explore the potential of radar-evading aircraft. Unlike operational aircraft, it never truly existed, but it served as a public study to investigate low observability, reduced radar cross-section, and advanced shaping for future stealth technologies. The F-19 legend influenced public views on aircraft, like the F-117 Nighthawk and F-22 Raptors. The aircraft's design emphasized angular surfaces, internal weapons bays, and smooth integration of avionics to minimize radar reflections. Reducing radar cross-section involves shaping the aircraft so that radar waves scatter away from the source instead of reflecting back, and hiding engines or intakes to avoid detection by infrared sensors. The F-19's conceptual layout focused on balancing stealth characteristics with aerodynamic stability. Although largely speculative, the F-19 mirrored principles of stealth that would become critical for modern air combat. Observers debated factors such as heat signature management, electronic emissions control, and substances which absorb radar energy. Its cultural existence trailed substantial U.S. military research into low observable aircraft before stealth became operational in the 1980s. These examples highlight remarkable engineering and innovation in modern technology. If you enjoyed this video and want to discover more interesting content across different topics, subscribe to the channel for future updates.